Okay, number 2 has solving a quadratic function. Just because it says it's a quadratic function, remember, all that means is that it is a second-degree polynomial. So, it's a parabola. Now, they say solve it. That's because they've already given us a y value of 0. We have a product that's equal to 0. One of these two factors has to equal 0. That's called the zero product property. What we're going to do is we're going to split it up into two separate problems. We're going to solve x minus 4 equals 0 because that would give me a product of 0. And we're going to solve 3x minus 9 equals 0. And what we'll do is over here, we're going to add 4 to both sides. That gives me an answer of x equals 4 as one of my solutions. And in my other equation, I'm going to add 9 to both sides, which gives me 3x equals 9. And undo the multiplication with division, and I have a second solution of x equals 3. So combine those two, and the answers are x equals 3 and 4. Okay, what are the rules for qualifying as a polynomial function? Question number 3. The rules are easy. You could look these up in your book to confirm. Likely, what's going to happen on the final is you're going to get a set of, it's multiple choice, so there might be 4 equations, and they would say which one is not a polynomial or which one is a polynomial. What you're looking for is you're looking at the exponents. Okay, so what we want positive, well, let's say non-negative integer exponents. Now that's the biggest thing that we should look for. That is what is most likely not going to be seen if something is not. So some examples, if you have an equation like this, that's fine. That's fine. Still fine. Right? We're just looking at the exponents. As long as they are not negative, this one has an exponent of 1. This one has an exponent of 0, right? This is x to the 0 power. So what you would not want to see would be things like this, because that's the same as this. Or something like that. These you would not want to see. So that's the simplest thing. You're going to look for non-negative integer exponents. The ones that we've been working with all have one variable, typically x. So you're looking for y equals, and then your x's will have your exponents. Doesn't matter what your coefficients are, these numbers out in front of the variables. They can be negative. They can be square roots. I'm not worried about them. I'm worried about the powers of the variables. Yes? First one is non-negative, so this would be okay. This one, that has a fractional, so not an integer. So you just want to be careful. No fractions, right? Square roots and fractional powers. That's our that's some of our rules of exponents that we learned earlier. And then any positive power down in the denominator is like a negative power in the numerator. So that's why that second one was disqualified. Okay, let's find the vertex of this parabola by completing the square. Completing the square was a process whereby we would look to find a perfect square in this quadratic equation. So what we would do is we would separate it first. We would leave ourselves a little bit of space here. So we would rewrite this like this. Now, the reason that we did that, what we're looking for is we're looking for a number that we could put We're okay. Little technical glitch there. We're back on. We're looking for a number that we could put inside these parentheses and balance out here so that inside the parentheses we would have a perfect square. We take half of the 8 and square it in this case, and that's going to be a 16. We're going to balance that with a minus 16 on the outside. These two have a net effect of 0. Now what we've got, though, is we've got an equation that we can write. See, this is x minus 4 squared, and then outside we've got a 28. Now what that enables me to do, I rewrote everything that was inside the parentheses as a perfect square. You could FOIL this back out to confirm that. I just factored it. And then negative 12 minus 16 is negative 28. What that does, these two values are this in vertex form, right? Y equals x minus h squared plus k. That's vertex form. So those two green values, in our case a 4 and a negative 28, that makes the vertex of the parabola. That just means where it's going to change directions. Okay, let's use the finite differences method to find the degree of the function that models this data. Finite differences, what we learned was that we started looking at the differences in if our input values, our x values, or in this case our u values, were evenly spaced, like these are, 1, 2, 3, 4. Then we looked at the difference in the output y values, u sub n values in this case. So this was plus 1, then we went up 7, then we went up 19, and then we went up, what's that, 37. Thank you. All right, so from here, we look at these. So this counted up 6, and we counted up 12, and then we counted up 18. Now, as soon as we hit the same number, up 6 and up 6. As soon as that happens, this was our third round of finding the differences. That's the degree of our polynomial, meaning that's the degree of the function modeling this data. That's the highest exponent in our function.